Now let me clean it and discuss about remove, compute, restore, sham, and the application of the spectral form in that. We write Stokes integral again and equal all over 4 pi comma integral over here delta g prime. I will give some distance here. We'll explain later. The Stokes function multiplied by the sigma. So the simplification. Remove normally means to remove the long wavelength portion of data from gravity data. This means that we can use an S gravity model to a specific degree and subtract it from the data. In that case, we remove the portion. The long wavelength portion of the data, as this is spectral, the more special spectral harmonic expansion. So delta G to infinity is zero formally. The harmonic expansion of gravity anomaly, but if I limit the maximum degree to the infinity to L, then I will have one portion if L is not too low. For example, in EGM 2008, this maximum degree will be 2160 or partially to 2190. But for the satellites only models, it will be around 300. So the galactic anomaly computed using gravity must verify harmonic synthesis and harmonic properties. To that maximum degree, specific degree, can be subtracted from the data. This step is called remove. Remove. It means that it is removed from the data. The data without the long-term portions are used to compute the theory. But since the data misses long-term portion, what we get out of it is not a complete theory. It will be some frequencies of the theory, or can say high frequencies of it. Thereafter, the low frequencies should be added back to the solution. For example, here I can remove the delta G prime L from data. This is the first step. I'll remove computer storage scheme or sham. I remove this one. What I get will not be zeroed anymore. It should be it will be some frequencies of G. And therefore I need to but I will explain what should be added back. Let me rewrite this integral back to a summation and the 2 up to L and Laplace harmonic set. It means that I use the gravity model and compute the gravity anomaly, remove it from the gravity data. That is the first step of move as compute the step. Then I take the integral and compute this theory. But it is not complete theory, it's frequencies of the theory or frequencies of the theory. Step 2, which is compute. And step 3 is that I use the same gravity model, but instead of computing the gravity anomaly, this time I compute the theory directly and will add it back to computed microfrequency theory. That's the principle of the remove, compute, restore method. And how is this correct? I will explain it here. Like the integral of n for pi g the gamma the prime and sign is minus for pi gamma integral g prime L is like the portion of is fine. So I just expand the first term to this dot. And so the first term, if I write the spectral form for them, is the summation from the 2 to infinity plus 1 delta Gn. The second term actually will be the summation of the 2 pi to r over 2 gamma summation 2 up to L over minus 1 delta Gn plus the last term. If I write this n as this in terms of the Laplace coefficients of gravity anomaly, it will be r over 2 gamma n to 2 to L 2 and plus 1 and then touch it. And as you see, the last two terms are equal in opposite directions, opposite signs. I will write n is equal to the negative one is removed over 2 gamma and the positive one will be n to infinity 2 and plus 2 and minus 1 delta G n minus the second term. The second term was the second integral. And how can we write the second integral? The second term is the equation and in that spectral form. Discussion here. Let me show how can we write this. Here I just want to say that it is I will write n is equal to the result will be the same. And 2 to infinity 2 and plus 2 and minus 1 delta G n minus the second term. The second term was 2 L. Actually it is n. Now let us write the integral formula that I mentioned. Delta G prime L. Here I just want to say They are the same. That it is for the results will be the same. And we do L delta G to how can it be correct? That's the main question. Okay, I realize the formula that I mentioned. Instead of delta G prime L, the gravity suction anomaly of the leveling, I will write the spherical harmonics for delta G and L, phi and M delta G sigma lambda to how can it be correct? Degree maximum errors. And the spectral form of this Stokes function, I rewrite the equation. But that this is important that you should instead of saying the gravity degree and harmony of this wire or template, I will write the spherical harmonics for so G and M, phi and M, N plus phi lambda minus P N plus phi. This is actually the addition theorem of the degree maximum degree. Then I will continue and spectral form of the harmonic expression of the gravity anomaly. But that this is important that you should end the same y degree and order. This y or from the front. With my n so and 5 and minus 1. N plus 5 minus y n plus 5. This is actually the transition theorem of spectrum. And then I will continue the point as a prime the harmonic expression of the gravity anomaly. So we already know why we have the prime along the prime here, prime and the prime, y prime and prime. According to the addition theorem of spectrum, according to the orthogonality properties of the spectral harmonics, we have y and n and prime. Right? And the integral the spectral harmonics prime as a prime integration point, different equation order, with the 4 prime. So we already know we have the prime along the prime here. We should be small prime the prime thing. If I insert them back, addition theorem of spectrum, formula, orthogonality properties of the spectral harmonics, we have this means that the integral the spectral harmonics, same integration points, different equation order, with the 4 prime. We should be should be kilometers there. If I insert them back, inside formula will be all of them on summation of the my expansion of gravity and also the spectral form of the will be all of them on summation of the my expansion of gravity and of my kernel and prime. And I connected it one only the spectral form to in an prime equal. Therefore, it will kill all high degrees than L. engage. Quickly formaters data and fine formatter can try and the formatter data will form only if it is true and therefore we come to the critical harmonic functional diagram it will help for factorizing terms of Laplace coefficient. It will be all over gamma in the summation from the group 2 up to L 1 over M 1. That's it. Therefore, we come to the critical harmonic functional diagram to be help for factorizing terms of Laplace coefficient. It will be all over gamma summation from the group 2 up to L 1 over M 1. That's it.